here. I've got a Ford Transit. It's a 2013 with engine management lights on and what have you. Apparently somebody has been out and done a DBF clean on it recently, and it's now blocked again, but I'll always try and find cause rather than just treat the symptom. So this fault here interests me: manifold absolute pressure sensor, barometric pressure correlation. It's a fault which, if I clear it and as soon as I cycle the ignition and start the van up, the fault comes back, and I'm going to show you why. So if I go to the live data for this vehicle at the manifold pressure, and it's at 39.25 kPa, it should be at 100 kPa. The engine's not running, so the pressure inside the manifold is atmospheric pressure. Atmospheric pressure is around about 100 kPa. So I've got a multimeter back probed into the sensor, and I've got a feedback voltage on a signal wire of 695 millivolts. The pressure it's reading is low, so I would assume that the voltage should be higher. So what I'm going to do is basically attach a decade box to it. So I'm going to unplug the sensor first. So as you see, if I unplug the sensor, the voltage goes high. And what happens is the manifold pressure goes to a default value, a known good value, which is 101 kPa, which would be the same as what the barometric pressure is. So I've got a decade box connected to ground, which is on the brake servo, and what I'm going to do, what I've done is I've introduced what I believe to be the correct voltage onto the circuit, which is 1.6 volts, and sure enough we have 100 kPa. So proving that there's nothing wrong with the wiring to this sensor, there's nothing wrong with the engine control unit, it's the sensor that's at fault. Now interestingly, I'll get you down there, and if you just look, non-genuine manifold pressure sensor, FAE1. Basically, these are the sensors that motor factors sell, motor factors that run around in blue vans mainly. They're basically not worth a squirt. So I'm going to order up a new sensor from Ford, which interestingly is just over 40 quid, so it's not exactly an expensive part. I'm going to fit it and then reassess this vehicle for the DBF problem. So another lesson, basically, don't buy cheap sensors, they don't work. Obviously the guy who's bought this sensor has replaced it for a reason, don't know why. Unfortunately the old sensor's not here for me to examine, but he's actually put a sensor on which is faulty. Was the old one faulty? It may have been, it may not have been, but we'll put a new one on, put one on that works anyway, and correct that fault, correct the DPF issue, and then reassess the vehicle. And here we have it from Ford, a genuine map sensor, which come to princely sum of about 30 odd quid to be fair. There we go, genuine Ford item. So I'm going to fit that in the engine now, and then we'll revisit this map sensor fault. Right, I've got the new map sensor, the Ford one, plugged into the harness. I've got the multimeter back on it just to check the feedback voltage from it. If you remember the decade box, we introduced about 1.6 volts into the circuit, which brought it to somewhere close to atmospheric pressure. The new sensor, 1.694 volts, is the feedback voltage on this sensor, and it's reading a manifold pressure of 105 kPa. So basically proved that the map sensor that was fitted was garbage. There it is there. If you're thinking about buying map sensors, don't buy map sensors made by FAA. They don't bloody work. And to be fair, this looks like a very new map sensor that's been fitted, so I would suggest that this is possibly one of the parts that have been fitted to this van by this other garage. What I have noticed as well is it's got a very new looking turbo actuator on it as well, so maybe it's just had a turbo actuator as well because of this map sensor fault. I don't know. Start the van back up again. Manifold pressure 108, 190 in the year. I'm going to pick the revs up now. Stick to press the throttle. See if it goes up. Now that's very interesting. It's gone up, but it took an age to go up. It's dropped back down there now. It's gone back to a substitute value. So the ECU is once again substitute the value of this map sensor. So I'm just going to switch ignition off and back on again. Start it up. 140 kPa. Now how interesting is this? And again it's substituted the value. So a little bit of detector working is done here. 2.2 volts and it's an idle. So the voltage on this map sensor has gone high. It's going to whip this bolt out. Pull this manifold pressure out. Let's see. I've pulled that manifold pressure sensor out of the manifold and the voltage has dropped immediately. So this pressure must be building up inside the port that the pressure sensor sits in. Which is odd because as soon as I stop revving, the pressure should drop. So next thing I'm going to do is I'm going to test this manifold pressure sensor with a device that I can apply pressure to and see how it reacts to changing the pressure. Yeah, as we've established, the signal voltage that the pressure sensor sends back to the ECU is relative, or what the ECU translates as the pressure is relative to the signal voltage coming from this sensor. So I'm plugged back into this sensor. I've got my multimeter in the back probed into the signal wire, and I've got a pump attached to it. So as I apply pressure, this voltage will go up. So I'll just and there's the voltage going up, and then when I release the pressure, the voltage goes down immediately. So before on the engine it wasn't, the voltage didn't go down until I pulled the sensor out of the manifold. So that tells me there's an issue with this manifold. The orifice, should we say, the hole that the sensor sits in, this hole here, as I say, when I revved it, it was very, very slow at picking up pressure, but when it did pick up pressure, the pressure stayed there after I dropped the revs, and it didn't drop until I pulled the sensor out. So there's a problem with the relationship between this manifold and the sensor. Could the hole be restricted? So if there's a restriction, the pressure's eventually getting through. When I rev it hard enough, it'll eventually work its way through to the where the sensor's mounted. But is it it's not relieving that pressure. It's like as if it's got a one-way valve on it. So we need to investigate further with this inlet manifold. Yeah, so I think the next thing to do is I'm going to use a smoke machine and I'm going to introduce some smoke into the air intake. I'm going to leave the pressure sensor out of the manifold and first of all see how much smoke comes out this hole, because if there's little or none, then we've got a restriction in the manifold where the pressure sensor goes. But there we go, smoke machine's all set up. I'm going to put this device, which is called an easy air intake, into the, it's an inflatable bladder basically. Push that into the air intake. I'll inflate that and connect the smoke machine to it. Right, I've got the easy air intake inside the inlet intake there, and I've inflated it. This pipe here basically goes straight through the inflatable ball, and then that's what we connect the smoke onto. So plausibility check first. We'll set the smoke machine up. Now this engine is capable of about 1 and a bit bar of positive pressure. 2 is probably too much, so 1.5 bar, 1. Set it away. Make sure I've got smoke, which I have. Smoke coming out of there, and I'm going to connect that onto the easy air intake. Quick coupler there, so that's connected on. And now we need to see if any smoke comes out of this inlet manifold. I've still got the manifold pressure sensor out of the manifold, so I've got the light on there. And as you can see, there's no smoke coming out of this hole where the manifold pressure lives. There's also no air coming out of it either. So that tells me that there's an issue with this manifold. I would be expecting smoke to be billowing out of here, to be fair. And there's next to nothing coming out of it. Well, there's nothing coming out of it, not even next to nothing. There's actually no smoke at all coming out of there. You would see it through the light. So what we would appear to have is an issue inside this inlet manifold. I've got here is a little straw. I'm just going to poke it in there, see if I can remove a restriction of any description. Out. What's worth noting is the pressure's built up inside the engine because I'm starting to get smoke coming out of the filler cap. So there's pressure building up. The reason I'm getting smoke coming out the filler cap is because of the breather pipe here on the air intake. It's also filling the rotor cover as well. So that tells me that the smoke machine's doing its job. It's pressurising the engine. As you see, nothing coming out the inlet manifold. So you got the better of us, and I've stopped back tonight to get this manifold off to see what's going on. Now, I've tried blowing down that hole and I can't blow down it. So it's absolutely blocked solid with something. As you can see, there's quite a bit of carbon inside the manifold there. So it's kind of difficult to see where the hole would be. What I'll do is scrape some of that away and have a look.